I'm going to pull our data from the first period section, 29, 6, 10, and 11 for our number of colleges we're going to apply to, and I'm going to work through the actual calculation for standard deviation. We'll do this once, and then there's a couple nuggets that you need to use, and then for the most part, we're just going to use technology this year, whether it's computer or graphing calculator or whatever it may be. The key is we want to know what it's saying and how to interpret it. So I'm going to take those data points. I do need to know my mean for this data set. So the mean for standard deviation for this data set, if you plug it in, is going to end up being 11.2. And this is just good notation. Mean is written with an X bar. So anytime you see X bar, that is your mean for 11.2. So I'm going to come over here. Distance from the mean is just asking you to subtract. So this one right here is going to be 20 minus 11.2 and so on. And you're just going to make your way down the whole list. So I'm going to cut to the chase, and my numbers here are going to be 8.8. And then I'm going to have negative 2.2, negative 5.2, negative 1.2, and negative 0.2. Once you have those numbers, it then says to take your distance from the mean, this column, and square it. So you just take each number and square it. So like this first one would be 8.8 squared, and so on. So again, just writing the numbers: 77.44, 4.84, 27.04, 1.44, and 0.04. We then need to find the total, meaning we add up these numbers in order to find our total. So I'm going to switch over, and our total is going to be 738. Adding up, that's not right. That's not 738. I don't know what number I was looking at. Let's try that again. So let's see. We're going to have 77.44 plus 4.84 plus 27.04 plus 1.44 plus 0.04. 110.8. Sounds a little bit better. So 110.8. And then finally, we then take the average distance from the mean squared. So I'm going to take that 110.8 and I'm going to divide by our 5 data points. And so when I divide by 5, I get 22.6, or 16, sorry. And then if I wanted to finish my standard deviation, what I'm going to do is take note of the fact that my standard deviation, we squared our numbers in order to make them positive. So at the end, I need to take a square root. So I'm going to take the square root of that 22.16, and I end up with 4.707 as my standard deviation. Now, when we look at this, I'm going to take a moment right now, pardon me, and highlight the notation, because this is not what you're going to see on a test or a quiz or the AP study book. You're going to see this gnarly equation, so I want to build it with you. I established that our mean is X bar. Every data point or value is just X, okay? So in other words, right here, in order to find the distance from the mean, we took X and subtracted X bar, okay? Then we squared it. So we took X minus X bar and then squared it. And then we took all of our values for our 5 data points and said, hey, we need to find the total, add them up. What's our symbol for adding up numbers? That is going to be sigma. And so we've got sigma of X minus X bar squared. And then for that next line, we said, hey, we need to divide by how many values we had. The number of values you have is just the letter N. So then this box right here says, hey, x minus x, minus x bar squared all over n. Okay, I'm going to put a little bit of whiteout right there because I don't want to redo the whole thing. That's just x minus x bar. Oh, there was a lot of whiteout on there. Okay, abandon ship. Let's try this again. So we're going to go sigma x minus x bar squared all over n. And then finally our last step to get down here was to realize, hey, that's got to be under your square root. So we've got sigma x minus x bar squared over n in order to get our standard deviation. And if you see this, it looks like what in the world is going on because there's a ton. But think about what our individual steps are. Take your data point, subtract the mean, square the number you get, add them all up, divide by n to find an average, take a square root. The individual steps aren't too bad. Don't worry about copying this down because I'm going to put a small edit on this calculation, so please tune in to part 3.